All right, here we're still in AP Stat. We're in Unit 1 still, kind of going over the different graphs and charts and everything else right now and how to organize and graphically display a lot of our data right now. We were getting done with histograms and looking at the relative frequencies of those. And just giving you another tip here because I like to enjoy giving you tips for your exam as you keep going because ultimately you're all trying to take that. It says relative frequencies are the usual choice, which is the percentages, when comparing distributions of different sizes. Because if you can make everything in terms of a percent, it doesn't necessarily matter about how many different people are in it. It's easier to compare one distribution to another if they're all involved in percentages instead. So although it is usually not possible to divide a histogram so nicely into 10 parts, I mean, that was the last example here. It's not always so convenient and easy to do that. The principle of the relative frequencies corresponding to relative areas is still there, like the idea, the principle of comparing one to the other. So note how this example shows the number of exam scores falling between certain areas, whereas the previous two showed the exact number of AP scores, right? The AP classes taken or the exact number of shoes, right? So you can use this for a range or you could use this for exact scores as well. We also have stem and leaf plots now. Okay, so we also have the stem and leaf plots. And although histogram may show how many scores fall into each grouping or interval, the exact values of individual scores are lost. You get a range, you get like a relative frequency, you get a grouping, right, of what falls there, but we don't get the exact individual scores that are there. Whereas stem plots, you would. An alternative pictorial display that would show more about what's happening with the exact numbers is a stem plot. And some may have referred to this way back in like algebra classes and pre-algebra classes. They called this a stem and leaf plot. Stem plots retain the individual information, each individual number, for example, and make the information useful for giving quick overviews of a distribution. All right, by displaying the relative density and shape of the curve. You'll still end up getting it. The point is, you plug in each individual number and it has weight, it has merit to it, and it'll still give you a shape of what the graph should look like. A stem plot contains two columns separated by vertical lines. The left column contains the stems and the right column contains the leaves. Again, if I'm moving too fast for you, pause the video, write this stuff down. Okay, that's all you got to do. So an example. Horrible at pronouncing medicines, all right, in this scientific stuff. So we'll go with bisphenol, all right, A, is an industrial chemical that is found in many hard plastic bottles. It is called the BPA, which is how I refer to it whenever I see it on a bottle. Recent studies have shown a possible link between the BPA exposure and childhood obesity, okay? In one study of 27 elementary school children, the urinary BPA levels in nanogram milliliters were as follows. So here's a huge list. Just pause the video and write them all down. Okay, that's all you got to do. Pause the video, write them all down. But here's the list of all of them. All right, of all 27 individual kids. So how do you take the data and organize it, basically? Here is the stem and leaf plot. All right. Each that has a zero out in front is there. Imagine this is kind of like your decimal, and these are all the numbers after it. And they are listed in order, okay? They're all listed in order. 0.2, 0.4, 0.7, 0.7, 0.8, 0.8, 0.9, right? 1.0, 1.3, 1.4, 1.7s, right? They're all listed in there, all right? And it looks like I might be missing. This is the graph that was given. I think I am missing, if you're writing this down, because it looks like there are three 1.4s there, so I need another 1.4 and a 1.4. It looks like are cut off from this when you're writing it down, so keep that in mind. I don't think I'm missing any others from the chart, but yes, I'm definitely missing two 1.4s. So this is accurate. This stem and leaf plot is accurate. This is just missing one of them. Take another look at a different example, and this is showing you how to write it, mainly more than anything. So this is wrong. You should have an extra 1.4 and 1.4 in there. Okay. There you go. I added those in, so now we have the three 1.4s. So we're all fixed up. We're all ready to go. All right, to take another look at a different example, how many nonstop push-ups can a 15 to 18-year-old teenager do? Ooh. So in one study in a mixed-gender high school gym class, the number of push-ups were as follows, right? So here's what the kids could do in the class nonstop. 50 push-ups nonstop. Holy moly, right? So here is the STEM plot. This is how it would look, written down with all that data. So pause the video, write down all the data. Right, this would be a 0, 2, 0, 5, 0, 7. These would all be 1s and then whatever comes right out in front of it. And here's what it looks like. So as you're looking at this, it's looking like people, for the most part, were right smack dab in this area of in between the teens and the 30s, actually, of having the most done more than anything, right? They look about the same. And it says, we can look at centers and spreads easier when we're looking at this data. It says, looking at a graphical display, we see that the two important aspects of the overall pattern are, right, two aspects of this are a center, which separates the values or areas under the curve, in the case of a histogram, roughly in half. And two, a spread, which is the scope of the values from smallest to largest. That's your spread, from smallest to largest. The center separates the values or the areas under the curve, in the case of a histogram, in half. Okay, so here's a tip. Center and spread should always be described together. When you're talking about them, they always get described together. Don't just do one. What I'm implying is do them both. Go with center and with spread. So, in the histogram example earlier, the center is 2 AP classes while the spread is 0 to 4, right? This was the idea, right? The center right there in the middle, and the spread is from 0 to 4 AP classes. Got it? Right? Center, spread. In the other histogram example from earlier, the center is about 19, and the spread is from 5 to 60, right? 5 is the lowest, 60 is the high, but the center, because that was around where 50% is about 19. That's where half of it is. So it's where 50% is. That is the center, literally 50%. And the other histogram example from earlier, he had a center at 80 with a spread of 60 to 100. And why? Because if we separate all these, this is about 1, 2, 3, 4, 5, right here. 80 is the center. That's about half, and that's about half right there. All right, and the spread was between 60 and 100. Even at the STEM plot example, the first one had a center of 1.7, which was the middle of the 27 values, and a spread from 0.2 to 0.5, right? The middle of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, said 13, 14, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, so it was around there, right? That's roughly where the center is, somewhere in between there. And lastly, the STEM plot of push-ups had a center at 21, which was the middle of the 25 values, and a spread from 2 to 50, right? 2 to 50. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And then 13 is the middle, and then 12 more. 21's right smack dab in the center of the data. That's the middle. The spread was from 2 to 50. Next up is something that we call clusters and grouping. All right, sorry, clusters and gaps. So the center and the spread we got. And now we have clusters and gaps. And there are two other important aspects to the overall pattern of data. Clusters, which show the natural subgroups into which the values fall. We had some subgroups and some examples we've had here. So for example, the salaries of teachers in Ithaca, New York fall in 3 overlapping clusters. One for public school teachers, one for Ithaca College professors, and the other for Cornell University professors. Those are the clusters, right? Gaps show holes where no values fall. That's literally what you would think. It's a gap, and there's no value there. So for example, the office of the dean sends letters to students being put on the honor roll, and to do those being put on academic warning for low grades. All right. Thus, the GPA distribution of students receiving letters from the dean has a huge middle gap. Think about it. You're on academic probation, or you're in the honor roll. It's the only time they're sending anything home. It's the same with parents in school. I contact parents all the time. I contact them if their kids aren't doing well, and I contact them if their kids are doing well, but I don't ever really contact anyone in the middle. Big gap, right? People who's doing okay. Yeah, you're just doing okay. I don't contact mom and say, you know what, he's doing okay. That's the middle gap that we're talking about. So, taking a look at this example, Hodgkin's lymphoma is a cancer of the lymphatic system and the system that drains excess fluid from the blood and protects against infection, considering the following histogram, right? This is a rough histogram. I know you're used to seeing them as blocks. It's just like an outline of it. Female cases of Hodgkin's lymphoma, this is their ages when they are diagnosed, and this is the rate per 100,000. So all these are 100,000s, basically. And as you can see, it looks like we have a cluster here and a cluster here. We have two clusters. Simply saying that the average age at diagnosis for a female is around 50 clearly misses the point. Yeah, the average age is 50. Okay, but where are people mainly classified? Oh, right in between here. There seems to be a peak right here, and there seems to be a peak right here. Yeah, averaging it all together, I certainly very well might end up getting 50. It's right in the middle of my histogram. But this and this, those are more important to take a look at, right? The distribution of ages at diagnosed for female cases of Hodgkin's lymphoma is a bimodal, bi meaning two, with two distinct clusters centered around 25 and centered around 75. Those are the bigger clusters and bigger areas to focus on. It kind of makes sense what I'm getting at there. All right, even though technically I could average it all out and say, well, that's the middle, that's your center of your data. It is, but the center is not really important. What's more important is there seems to be two clusters where people are getting more cases of Hodgkin's lymphoma, around 25 and around 75. Bigger deal, right? All right, when we come back here, we'll talk about outliers.